Happy Monday. Right? Cheers to Monday? Yeah. So I thought, there it is. Well, welcome to the Nerdery. We're glad everyone could make it, especially for the AI Meetup group this evening. So we have Matt Versace. There we go. He is the Senior Director of AI and Machine Learning from Optum. We met a while back and have stayed in touch, and he told me about the great meetup group, and we were happy to host. So thank you all for coming. Hope you're enjoying yourself so far. And Sergey Tolkachev, correct? Okay, perfect, is here as our keynote speaker. And so really how the evening will go is Matt's going to do an introduction for the meetup group, and Sergey will speak and do his presentation for us. Following, everyone will be able to meet back out in the kitchen, so we'll clear out the Nerdatorium. And any questions or just a little bit more time to hang out with each other is welcome. The doors do close at 8, so we're going to ask everyone to try to start filtering out by 7:45, and the doors lock, so don't forget anything because you will not be able to get back in. So welcome everyone, and thank you again. Thank you, Matt and Sergey, for being here. We're excited to have you. So I'm going to hand it over to Matt. Thanks, everyone.
All right. Thank you very much. Thank you guys for coming. You guys are at a distinct advantage. You guys have got at least 2 beers in you, and we have none. So after this, we're going to probably try to catch up. So please join us out there and help celebrate the end of this. Thank you for helping out some of the faces that I know in the crowd. And thank you guys for coming. I'm not used to a microphone. I'm used to just speaking in an auditorium. Matt Versace, Senior Director of AI and Machine Learning over at Optum for one of their divisions. My background's in both AI. I'm one of those weird characters that's got an AI background, data science, machine learning, computer science kind of background, as well as a business background, both the undergrad and grad, both of those sides. I'm an education nut. Was a professor at a university for a while. Worked as an AI engineer for a military contractor before that. Had an entrepreneurial experience for about 20 years before that. So I've kind of been all across the board. So I have some reasonable experiences that I hope I can share. So the group. The reason that we want to get this particular group together is to get folks who are in the executive level, in the education level, in the practitioner level, and the academic level, from students to CEOs who are interested in this particular technology, to get together and begin sharing ideas. The only reason I'm here is because when I went online to go find a group to join, I'm like, there has to be an AI group in the Minneapolis area to join. Where is it? And there was none. So I figured, come on. So a couple hours worth of considering, and I thought, all right, let's pull the trigger and do it. So what that tells me is that this field is going to change the world, and there's not a lot of organization going on in it. So what we want to do is begin to create some of those environments where a CEO can come down and talk to a guy who's making this stuff in the trenches and actually get a feel for what's happening. You know, the guys who are in marketing can come and talk to someone who's building neural networks or building deep learning networks or experimenting with intelligent agents in some fashion and get an understanding of what's going on without the pretenses of the business imposing upon that within their own environment. So we want to get people of different backgrounds, different perspectives, from medical to industry to gaming to the hardware. How many hardware guys are in here? There's a lot of NVIDIA guys and some other hardware guys in here. You know, all of these people to get together and begin to talk more in this industry. I think that's vital, and that's the reason that we're here. I think the other thing is that I don't have to really enunciate to this group is the gravity of the situation we find ourselves in right now when it comes to AI, machine learning, and the ability to change the world moving forward. We're at a unique inflection point in history. The kinds of things that are coming together from data, from hardware, from the ability to have the really strong, solid, open source, free algorithms that anybody can use are there. Never before in history have we seen this. So we're really at an inflection point in history where it's a real privilege to be here. Things are going to change, and this group and groups like this across the country and across the world are the folks who are going to be making those kinds of changes. That's exciting. So that was one of the other reasons to get in here, is to get all these people who are really going to push this from the forefront in a room and talking to people over a few beers and kind of cross-collaborating. But I will say, excuse me, I've been talking to a lot, so my voice is going. I will say a word of caution, aside from the fact that the doors do close at 8, and they're not kidding. So if you left your keys in here, you're going to have to bang on the door and hopefully somebody comes. Just do this. No, the word of caution is that because there's so much change, and because the technology is changing faster than the ethics, right? There's a very strong possibility, especially for everyone in this room, to find yourself in the not so near future in a situation where your ethics are tested because of the nature and the very sharp tools that this technology provides. And I would hope that it's going to take two things. It's going to take character to make the right decision, and it's going to take courage to make that right decision. And I hope that you have them both. So that's my only word of caution, because this technology is going to change the world. It's changing things as we can see it right now. You know, we have arguably a sitting president that was put into that space because of machine learning and data science, and some say artificial intelligence. That's powerful. Can you imagine what we'll do in the future? So this is a great place to be. It's a really incredible time in history for this technology and the people that are pushing it. And don't discount for a second how important you guys are and this technology you're playing with. So that's my one word. And so in that, I want to introduce my colleague, Sergey. And he's going to be, this is the problem when you get old, is you leave your bifocals at home. And you're like, you have to hold pieces of paper this far away. Sergey is going to talk about AI and how it intersects with the healthcare space and the intersection of a number of technologies, from neural networks to rule-based systems to a number of those things. And without kind of butchering it, I'm just going to kind of pass over the baton and hand it over. So thank you guys all for coming, for making this. It's amazing to be here and see all the faces in this crowd, and I couldn't be more happy. Thank you very much. Thanks for coming, guys.
Yeah, that's really an honor to be in front of you guys. And thank you, Matt. Thank you for that. I will start from the very first declaration. My job today is to surprise you. That's my job. And surprising for me means a lot, because I can measure surprise. It could be small surprise, big surprise, and surprise lead to interesting thing called probability. So if I will say and show something less probable than normal, so I will be very glad to show that if it's interesting and make sense for you. So probability lead to information, and information, that's what my area. So I graduated from information science, and my thesis was based on the information, and information in my blood. So that's what my very, very, how to say, big trigger and big passion. I know that artificial intelligence, it's a very interesting area, and I brought this book as an example. Great book, but very few words about information. And I will try to add as much as possible to the current trend in machine learning, in big data, in all this interesting trends happens in artificial intelligence, mostly based on the information. So bits and bytes, that's information measure. So that's why bits and bytes for me, it's not just English words, but also the measurement of something. And when I learned that I will be giving a presentation, I put on my desk a lot of notes, and you see some of them. It's not about, the very first one is, excuse me, if I'll say something, And my English, of course, it's a second language, so it's not necessarily what I think and what I say, it's maybe disconnected. So that's the very first note. But then plenty other ideas come to my mind. So about artificial intelligence is about machines. And machines there are the energy machines, machines for working with energy and machines for working with information, and many other stuff. So for example, for example, what's the similarity between healthcare and retailer in artificial intelligence? No, it's not about machine learning, but what the fundamentals interesting in thing. And then I recall the very interesting moment when Steve Jobs opened Apple Store. So Apple Store, it was totally unique, totally new, and totally old approach, because he actually take idea from the hospital. There is a doctor, nurse, and receptionist. And the difference between nurse, doctor, and receptionist is a cost. And then talking about this, the different ideas, I think what would be my major point for today's presentation? So where I will try to wrap all the artificial intelligence from around what idea? And the cost is the money come in my mind. Because we have plenty of research in artificial intelligence and machine learning, but very few people approaching this having cost in mind. So if we create something, and it's something, it could be chatbot, it could be learning system, with not saving, so it may be not efficient. It's not efficient. So that was a focal point come in my mind when I want to make a presentation, and everything, including science and engineering and other stuff, will be around this little point, cost. So I found this. It's in depth.org, which actually calculate how much we're paying for the medical service. And you can see that difference between emergency room and urgent care room, quite significant. And in an article, I put this quote from that article. The question was the real question that should be answered, but by whom? So whom we need to ask, and where we need to find the interaction service which actually answer the question where to go, to emergency or to urgent care. So that's a question. Just a little bit of history, and I will come to the very first demo. I started working with, I could not say artificial intelligence was very, very fuzzy word at that time. It's 70s, early 70s. At the first time I learned about perceptron, about some pattern recognition algorithm. And that was the group on the left. So that's a computer center at that time. I just wonder how many women were in the computer industry at that time. Currently very few, but at that time, science, mathematics were very popular. And this is a group of students, together with Professor Cherkasky, which is participating in our meeting. We, in 2015, we created the very interesting solution, which is right here. So we, with the 6 students, starting from the scratch, we developed the virtual assistant, which help a patient to collect information about this, about the state. And let me make a little demo.
Now, let's see an example of how all this works in practice. Alexa, ask my doctor.
Welcome.
I'm taking new meditation.
Are you taking any antibiotic or antihistamine?
Yes, I am.
What did you take?
I took penicillin.
What day did you begin taking this medication?
on Monday.
All right. And this project was completed in 2 years ago by 6 students, starting from the scratch, and they all represent the different components: project manager, programmer, linguist, and everything. And they completed in 3 months. And recently, the Amazon make a presentation. So Amazon come in Minnesota and teach people to program this little device. And that was so complicated. And many people who participated at that at Amazon and Alexa training system understand that currently what Alexa is doing and what Amazon is doing with developing such kind of products is terrible. And it's not only terrible, it's also, if you think from Amazon about the shopping cart and everything, the shopping cart could be available from Siri, from Cortana, from Amazon. So it's not monopoly from Google and Target to have the shopping cart. It's just the very first step in obtaining the voice recognition tools, which now start to be a technology, and available for programmers to develop something. And here, that's an answer why students were so successful in developing this conversational or dialogue assistant, because they used model of neuron, biological neuron. This is not a machine learning system. It's a simple biological model of what we have in our brain. This neuron, and I will show you now. The very interesting thing, I call it experimental dish. This is a neuron. What biological neuron can do? Clone itself. Then, another very interesting thing, neurons connected. So they can connect each other. And about 30 years ago, strange question came in my mind, how that happens that neurons find each other? So how they connect in the brain? How the neuron A can find neuron B? And I believe I found the answer, which is now supported by fundamental research. It's called attractors. So attractors is something which create a gradient space and allow to nerve to grow in the brain. So I create this attractor. See the greenish? That's attractor which allow at the moment when it exists to create connections. So I can attract these neurons and connect them. Then I can create more connections. And at the beginning, it looks kind of naive. It's a simple game. What's the use connecting neurons and bringing them together? But with a little thing called cloning and sync, I can create useful systems called triggers, trees, loops, and everything based on this timing, clocking, attraction, connection sequences. But neurons not only connect each other, they also propagate signals. So if I will, and you see this red stuff, it's sparkling, that's propagating signals. And it's look chaotic, but it's not. I create right now, based on the timing sequence and the series, the triggers, linguistic triggers, which allow me to solve a lot of useful things. It's, for example, the linguistic variable color. It could be red, green, assign it to variable. So we have many variables, and this variable is actually a trigger with the states. this example built on the Java, and now I can stop it and show you. And show you one more example. This is a little bit advanced example. It's based on the same neural dish, but now it's PC. And what I'm going to do, I'm going to extract text, create a dictionary, and build neural network, input layer of neural network, based on these words. It's quite simple. I clone neurons, but now I'm using internet connection, because every neuron have the listener, an IP port, which allow to feel touch or get IP excitement from outside. So this is a network with sensors and listeners, which allow to send signals here, sending from the browser. This browser is sending the signals. And after I will set up this network, I can excite it. See this, the word off, cells, etc. So it's just, I'm reading this text and exciting the network. Again, it's quite simple and a little bit strange. But if we go to the next slide. That's what I'm building. That I call links, pipes, short and long-term memory. We have different components here, but Sony, Logitech, Kodak, and everything, that's exactly the linguistic trigger, which if you ask somebody about the model maker or phone or something, that's a state. And this state is in the neurons looks like this. And because excitation come in and trigger and excite neurons, the state of connection represent the state of context of conversation. So that's what I have here when I will start talking to Alexa or to Siri, and behind the scene you will get the state of neurons, which represent the dynamic conversation and the dynamic model. The use of these models is, and where the cost come from, based on the ability to connect models to database. So models itself without connection to database is pretty useless. But if we can create the parametrical space on the neurons and make this parametrical space dynamic, activate it and connect it to the database interface, so then we may learn something very interesting and very useful. This is an example of how I can create interface to real database and use this database to select the product. Let's see the example. Alexa, ask my shopping assistant.
Okay.
I'm looking for a hairstyle.
I'm looking for hairstyle.
Blonde.
Blue.
Blonde.
Blue.
Older. I'm looking for food.
Looking for food.
Looking for cameras.
Looking for cameras.
Sony.
Sony.
Black. I told you, that's not in my mind. I'm looking for a car. Alexa, ask my shopping assistant.
Okay.
Looking for car.
Looking for car.
White BMW.
White BMW.
SUV.
SUV.
Reset.
Reset.
Toyota.
Toyota.
Better.
Better.
Cheaper.
Cheaper.
That's example of conversation, which, as you understand, so. Shut up. And what you can see right now, that's pretty impressive because it's almost impossible to do it in traditional logic. Because in traditional logical API, which is available right now, you cannot keep context. Like maker is Toyota or BMW, color is white or green, and switch to the hairstyle. And maybe I am interested in the cameras. And what does it mean better? And what does it mean cheaper? So what does it mean better or best? I can show you the interesting things. Alexa, 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 ask my shopping assistant.
I'm not quite sure how to help you with that.
Alexa, ask my shopping assistant.
Okay.
Reset.
Reset.
The best.
The best.
But the very interesting moment in this, right here, is that the definition of the best, it's not logical. It's Lotfi Zadeh, if you're familiar with his works. It's a fuzzy logic which connect the linguistic term like older, better, to the numeric set, and I can work with this numeric set, moving logical slider to the better, to the cheaper, to the best, to the cheapest, and that's because I have neurons. So let's go to here. That's what happened when I'm using the linguistic variables like better, cheaper. So this is a level of excitement for particular neuron which is responsible for particular variables. So this may be the best. That may be, the trigger which has cost, money, productivity. And here, that's a linguistic trigger which allows me to keep Sony or Toyota or BMW or something which hold the context of conversation. Because in a conversation, it's important to hold context and play with words like BMW, white SUV, but then switch to Toyota, and they say around 20,000, and it will be all around the context based here. And then I'm sending requests to the database based on the simple transformation of this logic into the traditional SQL request. Now, this is old HyperCard. Many of you probably never heard about this, but that was one of the most successful projects in the history of Apple. The great programmer, Bill Atkinson, I'm honored to meet him once. He created, in a matter of the few months, the product which represent the future of the web. Product was based on the cards. And the cards, it's a flexible, programmable, interconnected structure which allow to actually to dynamically program the content of the page. And I'm proud I'm just create a hypercard in the web. So I create a set of cards, and every card is a container. It's an object which may be loaded with the different data plus functions. Now, in this case, it's not HyperTalk, but JavaScript. And the card can communicate And the result is, I will go to another demo. And now, welcome to 80s. One of the reasons I'm still using this as an example of software gone, programmers gone, language is gone, but neural network which sitting here and represent the logic and connection and interconnected log still exists and may be reused and replicated again because it's a logical connection. So what you can see here, it's a result of work between linguist and expert. And let's see, can you see the text? This is just example of questions. So I can click on this line and say, what's the brain? And answer will come from the card. And I can say your location, or what is your brain, etc. So all these hundreds and hundreds of questions, which created as a set of cards, connected to the neural network. And what you see in this different screen, it's just different view of neural network. This is a way how expert linguist, for example, or doctor or car seller, can see the problem. So the context, questions, answers, dictionary, that's my favorite. I show you in a previous demo this small dictionary. That's what dictionary looks like in the practice. This dictionary connected and activated when I send a request, what is your telephone? The words come to the dictionary, excite neurons. Neurons propagate signals to the associated layers, and then result generated from the cards. So it looks like a little bit simple, but let me show you, sorry about it. Let me show you something like this. This is a dialogue we developed for Capital One Bank. Bank has a lot of questions come from user, and usually it's, I forget my PIN, help me, what is, I miss my card. So all these different questions, like I need to open account, that's the triggers. Yellow are triggers, which triggered by questions come to the call center for the in this case it was Capital Bank conversation from the phone. We use Verizon voice recognition at the time. And this is quite simple. But what's behind the scene, that's actual neural network, what created behind this plain flow chart. That's where all these layers, connections come together, and you don't need to see it. It's useless. It's very complicated, but beautiful. And a friend of mine, Artyom Zaborsky, so he created just for fun. Because when you look at this, it's no use, but it's so beautiful. And if you look at if you look to these yellow triggers, we implement Russian and Spanish and English. So it's номер счета, it's Russian, then we have Spanish version. All of these connections using the three different languages going to the hidden layers, and through the hidden layers going to the responses, but from the banker. That's what it is. It's a simple. That's expert. That's what experts are supposed to have when experts think about the problem. Logic, flow, and simplicity. But behind the scene, the real neural network, which looks like this. Now, let's go. On this slide, I understand that developers and programmers, and they dealing with databases, languages, virtual machines, and neural network have exactly the same potential environments. Developer environments, instead of database, it's active data, where data connected and propagated through the signals. And here, this example, we develop, let me tell you a little bit story. In ATI, I was visiting professor at Boston University, and a friend of mine was a doctoral student at Harvard Medical College, and he asked me to help him to build the flow chart, the clinical algorithm to help doctors avoid cases and learn how to make decision in medicine. So I created a flow chart and then returned back to my university, and I tried to share this idea with a professor I know, and he told me, no, this is absolutely different. The real doctor work differently. Real doctors, they don't follow the algorithms. They follow the observations. An observation could be, okay, just color, smell, you hold your hand, how it started. And we created very interesting solution, which now in the background of many application developed in the neural network. And I can show you. This example. It's only four problems: appendicitis, cholecystitics, and about hundreds of symptoms. So the doctor, professor, see the problem differently. It's examination scheme, and anamnesis, and other questions, like beginning of the disease, abnormality in diet, and so and so. But how that work for decision making? So if I will ask the very first question, and that would be the beginning of the disease, and then I could ask another question. When clicking on the note, I actually excited an answer. And more. At any moment, I can go and make a decision and see what distribution of this particular randomly selected symptoms, how they lead to the decision making, and that's why it's constipation. Because it's all over abdomen. So from the doctor point of view, that symptom is very important for that particular stuff. I'm programmer. I'm listening for doctors, and doctors know how to do this. And doctors need to have tools like this. Not necessarily these tools, but tools like this. Because only doctors know the importance of beginning of the disease and localization. And that's what I call expert transferring knowledge from expert whatever idea into the formal system, which could be, of course, written on the paper, but if we combine flow chart and structure with the neurons, the efficiency, it's tremendous. That's what, when I start from the students, now I'm going back to the continue of the students' project, but in a little bit different way. So excuse me. Now I'm switching from okay, so this is a neural editor, the same neural editor which now connected to the voice recognition. And I will ask Alexa, ask my virtual.
Okay.
I have a headache.
Is it acute or moderate?
Moderate.
When it started,
Yesterday.
you use any medication?
Actually, I'm looking for a car.
Is that new or used car?
Used.
Sedan or SUV?
SUV.
Your price range?
Help me.
Do you want me to connect you to the real person?
Yes.
I just sent a message to Serge. He should respond shortly.
Good afternoon.
Good afternoon. Today is a very special day. My birthday.
Okay.
Any color preference?
Now, let's switch from Alexa to iPhone X. Reset.
I am 687 days.
Reset. Ah. Crashed. Reset.
Do you want us to tell local dealers about your search? Okay, all neurons set to neutral.
I'm looking for a new car. Not Anna. Help me. Let me restart. Oh. Now I'm a mess. I'm sorry. Okay, so
Command, disconnect.
all right. The reason for this demonstration, I want to show that Siri can communicate with the same neural network exactly the same as Alexa. So that's not Alexa proprietary, that's a Siri and Alexa talking to the little brain, which is behind this editor. And let's...
Okay, all neurons set to neutral. Neuron connect.
Probably I need to use my phone for this case. Reset.
Okay, all neurons set to neutral.
I'm looking for a car.
Is that new or used car?
Used.
Sedan, coupe or SUV?
The reason for this demo is to show that when we create, when we can separate voice recognition and speech recognition, so this engine may work independently from the channel. So it may work with Cortana, with Siri, with Alexa, and support it with exactly the same logic provided by expert. So expert create the conversation, and voice channel provide the stream voice to the text, and text could be interact with the engine. How much time I have? That's what I call reverse advertisement. By the way, talking about cars or cameras. And now we can go a little bit back to the science. So if from the structure of computer science, that was I can say that was a three major period in the history of computers: computational, logical, and cognitive. Today, New York Times published the article about the salary for the AI specialist, 300, 500,000, because of this. Skills. Skills, that's what the key word for the next generation of software problems. How to build skills. I just create few skills on the fly. And back to the very first surprise. I don't know how to say that, but for me, conversation based on the Kolmogorov, based on the very interesting concept. Actually, it's a beautiful theory. So if I have a problem, this problem could be solved in the minimum number of steps. So if I have the question, do you have this car, or do I have this problem? That answer could be obtained in the minimum number of steps. And that's lead to the cost. So when we come to the website or we come to the expert, the minimum time we spend in explaining our problems, the better the service and less cost would be behind. And that's Kolmogorov. How strange it looks like, but somehow Kolmogorov formulated the principle for all web designers and all future skill designers. So if we can create the best, shortest way to obtain data from the user, that would be the best from scientific criteria and best from the cost criteria. But that's where context is important. When I show you the demo about the BMW, or it's too expensive, let's switch to the cheaper. But still, I'm looking for SUV. If I have pain in the left and then I have a suddenly headache, that's still pain in the left should be kept in the system. And to have a little fun about the science and the current state of artificial intelligence, I add this diagram. So I am electrical engineer and from a little bit mathematician, but the modern change, what happens from Turing time, when machines were simple. It was one tape, one head, one program. To the von Neumann and modern solution, where it's multiple tapes and extremely parallel processing, because it's von Neumann introduced multiple heads, which works with a memory, and memory could be interpreted by the control, like a control unit or data, and that's what we have in neurons, because neurons create asynchronous, totally asynchronous stream of processes. So when we implement neural networks, we create highly parallel machine, because all neurons could be activated differently and propagate signals as brain is doing. Brain is propagating parallel signals in a highly parallel environment. And this is a new way to think of processing. We think when we learn algorithms, which are sequential, even parallel algorithms, which is still sequential, neurons require totally new way of thinking. And that's a little bit propaganda, but I believe it's important because the current state of bots is crazy. Just Microsoft has now, you see, it's 130,000 developers. And these developers now facing the problem like this. Web is page or click oriented. It's not conversational. Developers don't understand asynchronous, highly parallel environment required for skills. But market is great. And at the very end, that's my credo. That scientist and engineer, they doing the different jobs. The scientists usually go into the past. And Einstein is really great in definition of what scientist and engineer must do. And this is a book of my friend, Professor Cherkassky. And that's a picture of Jason, the man with the two faces. Sorry for that. The man with two faces. So one is looking to the past, and that's what science is doing. And engineers is looking for into the forward, into the future. And reality is here. And I have one more demo to show. Again, that's what you will see. I have a friend who is the greatest programmer I ever met in my life, Artem Zaborsky. He did this in 2 weeks. So he created the neural network, and everything what you will see, it's 10 million of neurons. He scanned a live journal and create gravitational neural network model which allow to self-clusterized. This is neural network. And every neuron attract each other based on linguistics content of the site. So they come and clusterized in the groups by themselves. It's not external algorithm implemented. It's internal self-learning system which reconfigure groups, and now these groups represent something. If you actually click at the point, you will see that somebody talking about politics, sport, porno, whatever. We don't know. We have no idea, but they grouped by themselves. So that's what this little brick called neuron can do with in the proper hands. And that's mostly it. And the very last slide, I will stop it here. Sorry for that. If anybody interested, of course I can give this video. It's another credo for me because it's this triangle, business, art, and technology. This is Stravinsky. And I'm working with dialogues all my life, 30 years, and building dialogues. And suddenly I found a very interesting, extremely interesting, it's in a book, Conversation with Stravinsky. So in this book, Stravinsky drew the music. And he drew the music exactly as a dialogue could be built. It could be linear dialogue. It could be, polyphonical dialogue. So all these dialogues come from music. And this is Stravinsky way to see the music. And when I look at this picture, and that's why art is a part of this triangle, part of this very interesting balance. Like business, cost, technology, and art come together. And as a result, you can see the self-clusterization of strange neuron world. That's it. Excuse me again for my English, it's terrible.
Thank you. So that concludes our keynote speaker, and we'll head out back into the kitchen. There's some food left. Beer is done. Just to let you guys know, it was done at 7. Besides Matt, of course, we'll let one slide there. Matt wanted me to communicate if anyone is interested in speaking at the next meetup, please speak with him in the kitchen hereafter. So thank you again, everyone. Have a great night.